All right. Welcome back to The Blockument, where we do crypto education through everyday conversations. How you doing today?
I am good.
You are good. I am good. We have a guest in the house today.
Yeah, surprise.
My name is Nate Talbot. I'm the executive director of the Detroit Blockchain Center. And sitting next to me is the lovely
Ashlee Rose, and I am just your average gal. I'm a mother and a reseller, and I am just trying to figure out more information on what all of this crypto and Bitcoin stuff is. So let's figure out what this is together.
Let's figure it out together. Today's show is pre-recorded, so we won't be able to do any live call-ins today. But we do have a special guest in the house today, right? We have Lightning Eric.
Lightning Eric.
Happy to be here.
Yeah, how you doing, Eric?
Doing well. All's well.
All is well. Eric is, we've known Eric for quite some time now in the Southeast Michigan sort of meetup scene. Eric has sort of been the go-to guy. He hits like all of them up.
I like meetups.
He likes meetups.
In person.
He likes sharing information, knowledgeable on the game.
Yes.
Bitcoiner, is that an appropriate?
Yeah. Pretty maximalist.
Yep. Bitcoin maximalist, which we need. If people who listen often, you might have heard I consider myself a Bitcoin mostimalist. Yep. Love the foundations of Bitcoin. Very curious on the technology happening on the other sides. I guess it's a little more curiosity, more than a curiosity for me. It's probably an obsession because I know a little too much to be just curious. I don't know. Ashley, what would you consider yourself? Like just agnostic and everything or what?
No, I'm definitely like Bitcoin curious. And as I'm learning more and more, I'm finding like I really like the idea and like what it's all about or what I've learned so far. So yeah, I haven't figured out a word for myself yet, but I'm gonna figure it out. I'm gonna coin it.
There you go, coin it. Appropriate. Today we're here to talk about layer 2s, side chains, and scalability. This is going to be a little bit more of an advanced episode, what we would deem as a like 201 level thing. If you don't know very basic blockchain stuff, you might want to go check out after this episode or right before listening to it some of the episodes we've done on like what is a blockchain and the what are money episodes, things like that to sort of get caught up. But Ashley's pretty good at stopping us all in our tracks if we do get a little too advanced and slowing it down. So I think even if you're sort of new to the space and just sort of curious, you should be able to follow along. But we will have other episodes. And you can always go to theblockument.com. We have links in all our episodes with resources to learn more about it, and you'll see the past episodes and whatnot. But yeah, we got layer 2, side chains, and scalability. So let's start with just layer 2s, Ashley. Give me your let's go with scalability because this is all about scalability. When you talk about layer 2s and side chains, you're really talking about scalability. And so I'd like your initial perspective. Okay. What is scalability? What does that even mean, and why do we care?
Okay, I think you might be proud of this.
All right.
So, as far as I've learned, Bitcoin has a little bit of an issue with scalability because it is so good with privacy, and so for scalability to be able to happen faster, you need to have, I don't know if the word is called applications or like something built on top to assist with Bitcoin. Are you proud?
I'm always proud of you. How do you feel about that summary, Eric?
So I take a step back and say that as networks become popular, more and more people are going to want to participate and do more things on them. Mm-hmm. So everything's going to face like a scalability issue if it's something that's going to be popular and people can work with. Right. So the two technologies that were brought up are ways to address scalability. They're also kind of, I would throw in there, that you were talking about the different types of coins out there. So sidechains and layer 2s can be a way to incorporate innovations that happen on different coins into an already popular network like Bitcoin. Right. So, for example, to get into like sidechains, one of the popular ones for Bitcoin's rootstock, and that's a way to incorporate Ethereum's like functionality into something that's pegged to Bitcoin.
Would that be kind of similar to like a wrapping situation, like where you would wrap the Ethereum in Bitcoin, kind of, or something like that?
Yeah, it's pretty similar. So I guess it's a good time to get into like the sidechain itself.
Well, first, two things. Sure. You brought up wrapping, and we just had an episode, I think it was Money versus Finance, where we talked about wrapping.
Yeah,
so
I brought it up.
You should probably go check out our Money versus Finance episode to learn a lot more about what it even means to like wrap Bitcoin onto Ethereum or Ethereum onto Bitcoin. And before we dive into like the sidechain piece, I want to probe scalability just a tidbit more, right? So we have this thing, right? We call it the trilemma. The big problem in any kind of blockchain, a decentralized communication sort of issue, right? You need it to have security, right? You need it to you want it to have scalability. You want people to be able to jump in and use it, on a mass basis. But and this is really what sets using any kind of crypto type architecture apart, is you need it to be decentralized, right? We don't want to have central entities controlling it. This was the innovation that was Bitcoin, right? Satoshi Nakamoto did not create anything new. He just took multiple technologies that already existed and tied them together to allow this decentralized communication. And it's the old age when I was doing just business. The narrative I lived by, especially when negotiating prices, was the fast, cheap, good, right?
Yeah.
I can give you something fast and I can give it to you cheap, but it's not going to be good. I can give it to you good and cheap. It ain't going to be fast or fast and cheap. You can play it. You can pick any two. You can't have all three. Yeah. And blockchain architectures, open distributed system architectures suffer the same problem, except with scalability, decentralization, and security. You can pick any two, but you can't have all three. And Bitcoin chose to have security and decentralization.
That's what I was trying to get at in my initial definition.
Yep. Well, okay, so you nailed it.
Are you proud of me now?
You nailed it. I'm so proud of you. And so we have to face scalability, and a lot of the most prominent chains, Bitcoin, Ethereum, almost all of them, well, no, a few of the select top chains have also chosen, for the most part, security and decentralization. They all suffer scalability ones, and the ones that don't suffer scalability gave up greatly, normally not on security, so they gave up greatly on decentralization, and at which point the argument comes, why not just stick with what we got? That's why we use a bank or institutions, right? They're scalable, they're secure, they're definitely not decentralized. So on that tip, so how do we address the scalability piece? And you were talking about like side chains and whatnot. So let's start off with just like a basic, like what is a side chain? How does that even work in general?
So for both side chains and layer 2s, they are separate networks, additional networks. So other computers exchanging other types of data, but it's linked to the base chain. So sidechain and the layer 2 are two different approaches to using that base chain's data, but building on top of it.
Right. So like you say they're separate networks, but like wasn't it be for most networks, you were talking about rootstock, which as a sidechain approach, how does that connect? How does that work to connect to Bitcoin? Is it using Bitcoin? How does it connect to them? What's the difference and where are the similarities? Or really, where's the similarity? Where are they together?
So a side chain means that it's going to be pegged to the currency. So it's going to use like Bitcoin itself. So that Bitcoin's generally going to be passed to a group of people operating as a federation. Okay. And they're going to issue a new token on a new network. And you do basically have to trust that this federation is going to be able to maintain that peg, is going to, when someone puts their coin in, that they're going to receive this new token. And then when someone wants to peg out, when they want to get back that base layer currency, that they're going to burn the currency that was created on the side chain. So they're almost always like federated, the peg in and peg out. And then they will have a network that's creating its own blockchain, and that may have consensus, kind of like Bitcoin does, or it could do its own way of doing it.
Why would we even want that?
Generally, these side chains are going to have additional like functionality, so they're geared towards making smart contracts.
Okay.
Oh, so that would be okay. So you would have the side chain so that you could have the smart contractness that like Ethereum has that Bitcoin was unable to support.
Yeah, but it's denominated in Bitcoin, and then it allows people to use their Bitcoin with an additional functionality, but a little bit of a loss of decentralization, I guess.
Right. You keep saying like federated, but what does that mean, federated?
That means that there's going to be a group of people or organizations that have to agree to exchanging the currency from the base layer to the new token.
Who nominates these people?
Whoever sets it up. Usually there's several dozen people involved, or exchanges, companies that are involved in the space.
So a bunch of banks might as well just get together, right, and do a federation.
They're probably out there doing that, yeah.
That's exactly what they're probably doing. All right. Well, all right. Interesting. And how does it... Well, go ahead.
Well, then, okay, so let's say that the banks did do that, but then would it be like common knowledge, like who is in the federation? So you can know, like, okay, this is, the Chase side chain, and this is like the Bitcoin DAO or Bitcoin Maxi like side chain, like, because then from there you'd be able to choose. Hopefully, if you had the knowledge, obviously, I would like to pick the Bitcoin Maxi's version of this. Or am I like making sense or not?
It's just data, so people could be sending data to things that they know really well and things that they don't know. So I think the federations are usually pretty like publicly known currently. I don't know if the memberships change, if there's any sort of like voting in and out, but there's like founding members, and they have a lot at stake to keep it all on the up and up.
So you mentioned root stack. So we're talking about scalability. So Bitcoin right now, the metric people use is the 7 transactions per second. I think that's really, it gets the message across. I think that's a pretty poor metric. I don't think people understand what that really means, because it's not like there's only 7 transactions that happen in a second. Bitcoin works in 10-minute blocks, right? And there's thousands of transactions that happen in each of those blocks. But the scalability problem is that we can only fit so many transactions in, and it's already at a 10-minute window in Bitcoin. Ethereum, after now that they're under proof of stake, Ethereum is down to, I think, about 7 to 10 seconds per block. You have some chains that are doing like 1 block every half second. But so when we're talking about scalability, right, it's like how many of those transactions can you fit in? If you're using a traditional, a more off-chain system like Visa, right, you're doing like tens of thousands of transactions within a second. And that's why I think they use that 7 transactions per second with Bitcoin. So on the side chain only note, like a root stock for Bitcoin, how does that fix the scalability issue? How does that increase the transaction throughput?
So I guess generally these other blockchains do have faster like block times, and they're basically loading more data into their chain at a faster rate. The layer 2s, I think, are really going to be the way to address like that transaction speed scalability, and we can talk about that, I guess, a little bit. Sure. But yeah, the side chains really add a lot of functionality, act a little faster. But yeah, you are kind of creating this other side network.
Now, I'm sort of fascinated by some of the recent developments in layer 2s. I know you're the specialist on the Bitcoin side. The only other place you're really seeing layer 2 conversations and sidechain conversations is Ethereum. I'd mentioned in another episode before that, I really feel like from like the 2010 or 11 when the first sort of altcoins came out, all the way up through like 2018, 2019, when people made different systems or different blockchain systems, they were trying to compete with Bitcoin. They were trying to make alternatives to Bitcoin. I feel like, especially since like the summer of DeFi, which was in the summer of 2019, that shifted. I don't think any altcoin right now is an alternative to Bitcoin. I think they're all trying to be alternatives to Ethereum. And therefore, they make bigger compromises on that trilemma we talked about, right? Most of them have given up centralization. Some of them have given up straight up security for it to compete with Ethereum. So Ethereum and Bitcoin, I think, are the only two real big projects focusing on layer 2 type things. And so I bring all this up to say, in the Ethereum space, the very first layer 2 that saw major traction was Polygon. A lot of people call it layer 2, but the Polygon implementation that came out, and that's the Matic token. If you're not familiar with the proper name of the actual chain, Polygon is the chain, Matic is the token. But they were really a side chain, and it operated similar to like how you were sort of describing, where they really ran their own consensus mechanism, right? What really differentiates blockchains are the consensus mechanism, how the proof of work, how you come to that sort of network agreement on the state of the current chain. Because their philosophy was like, yeah, layer 2s are going to be big time, but we don't know how to do them good yet. So we'll just do a side chain. They federated, just like what you're talking about. And now people, this is an era when like Ethereum fees, you were paying like maybe, if you were doing any kind of DeFi stuff, you might pay $100-something, $200. This is before NFTs were banging. And some of those gas fees got up to like several $100s just for the gas fee. So you could move over to the Polygon network, wrap that Ethereum up, which is just basically taking like your Ethereum and putting it into a smart contract. And, Ethereum, we didn't talk about this on the Wrapped. Go watch the Money vs. Finance episode to really dig into what wrapping is. Mm-hmm. But basically they took Ethereum. Ethereum is the core token, like Bitcoin is the core token. You have ERC20s on Ethereum where you can make your own token. Ethereum is not an ERC20, but if you want to interact on a side chain, you need to make it an ERC20. So you take core Ethereum and wrap it up into an ERC20 contract, and then that ERC20 contract can then go over to Polygon, and you have wrapped Ethereum over there where you can do all the stuff, right? And it's way cheaper and faster, and you can have higher throughput. That's how they partially solve the scalability issue, but in doing so, they drastically increased their decentralization problem. Because once you go federated, like Eric just said, right, you're talking about a handful of validators now. Yeah. So I want to get into maybe the layer 2s. For Ethereum, a layer 2, what that means is you're using the same consensus. You're using Ethereum's main chain consensus, right? Mm-hmm. And there's a lot of ways they're looking at doing that. There's like these zero knowledge proofs they're looking at doing things with. But it's basically allows you to go to this layer above Bitcoin, above Ethereum, transact on that layer, but all the confirmations and the consensus of the state, I guess what do? They take like snapshots, and that syncs with the Ethereum blockchain. So you look at the Ethereum blockchain for validity, but the transactions happen on the layer 2. That's pretty much how it would work on a Bitcoin network as well, right?
Yeah. So to me, a layer 2, you create a type of transaction that's structured a certain way, and it's structured in a way so that you can have another network that works with it.
Right.
And in the Bitcoin case, it's structured. This new transaction structured in such a way that people can exchange potential signatures. So they can kind of do this IOU system and pass along like a potential settlement of the currency. And then the transactions have to be structured in a way so if someone cheats or tries to cheat, that other people can prevent that.
So you brought up Rootstock, but like Lightning Network is the real popular piece on top of Bitcoin. Yep. Now I've struggled with Lightning Network somewhat, in really understanding how to define it, because it's not really a layer 2 and it's not really a side chain. I sort of call it like a layer 1.5. Am I wrong on that?
It's definitely a layer.
It's definitely a layer. It's definitely a layer, but it doesn't really fit neatly into the layer 2, and it's definitely not a side chain.
Yep.
So, like, what is it?
Well, why doesn't it fit into layer 2?
Well, because, to my understanding of how it operates, the layer 2 mechanism is like I said, that you pull off the main chain's consensus, but it's happening on sort of a transactional basis, right? So we've gotten to use the term epic within the blockchain community when you start talking about, so like for Bitcoin, for example, every 10 minutes is a block. That's just the transaction, that's the time for the blockchain to produce. But you might take, in theory, you might say, well, every 20 blocks we'll call an epic, and something special happens at that point. And that's sort of how the halvening happens, right? Every X amount of blocks, I forgot the exact number, but every X amount of blocks, the Bitcoin supply will be cut in half. So that's an epic if you're talking about the halvening. And so with a layer 2, like on Ethereum, if you're going to do an actual roll-up type thing, not a side chain, so Ethereum settles again, let's say every 10 seconds or so. Every 30 seconds, the layer 2 might do that snapshot. That would be the Ethereum epic. And that's how it stays in consensus with the core blockchain. Okay. It may not produce blocks as fast as the core blockchain, but it would sync its consensus there. Lightning Network is not it never routinely syncs consensus. Lightning Network is like, we're going to set up payment channels, similar to like a side chain, right? You're going to take my Bitcoin, I'll take my Bitcoin, and I'll sort of lock it up in not quite a smart contract, maybe a dumb contract, and issue the IOUs into the Lightning Network. And then in the Lightning Network, I can set up this direct channel with you. Okay. And right? And then you and me can just take, like, I'll have 1 Bitcoin in it, you'll have 1 Bitcoin. You are a store, I'm a individual. I go to your store often, I want to pay in Bitcoin, and you want to accept Bitcoin. Instead of us waiting 10 minutes and all that for confirmation, we go to Lightning Network. We both have a Bitcoin, and I'll send you a 1/10 of a Bitcoin, and then a 1/5 of a Bitcoin or whatever. I'm just sending this little feed. Maybe you send me a little Bitcoin back for change or for whatever purpose. Yeah. But we have this transaction channel back and forth. And that's just between us. Only you and me really know what's going on. And then when we're done doing business together, that can be in an hour or that could be in 10 years, right? Mm-hmm. Then we both say, one of us or both of us say, I'm done. And we resync to the Bitcoin network, which then looks at our balances and says, well, after all that back and forth, Nate, you have a half Bitcoin left. Ashlee, you have a Bitcoin and a half. And so when I port over, I'm going to port a whole Bitcoin and a half to your account and half to mine account. And that's how consensus is ran. And that's what makes it act sort of like a layer 2 and a side chain at the same time, which I call it like a layer 1.5. And then you can get more advanced with, like, this isn't a Lightning Network episode necessarily per se, but then, like, you might have a channel with Eric, and I don't, and I want to transact with Eric, and we set through channels, and you have this huge payment network thing.
Maybe the Lightning way is the actual layer 2, and the Ethereum way is like layer 1.1, if they need to get a snapshot and settle regularly. So,
maybe.
Take a shot.
Well, like many things in the space, and, I'm not a developer, and this can get highly technical on it, so there could be pieces I'm missing here. But as always, we'll link more resources so you can do deeper dives on that aspect. I haven't heard of very, very clear definitions of layer 2.
Right. That's kind of what
Usually they resort back to like the internet, right? And then you have your core internet, and you have like this TCP/IP, which is your base. And then you build on top of it. You build email servers on top of that, and you build the HTTP and the HTTPS on top of that, and www dot on top of that. And so you have all these stacks. That's where the concept of layers came from. Mm-hmm. And like Bitcoin or Ethereum would be that TCP/IP, the very base, the very first protocol. And so how you interact with those higher levels, I don't know that we've ever clearly, it's been defined.
Yeah, people like to have a term that neatly encapsulates things, but sometimes you can't. Sometimes you just got a new thing that crosses definitions.
Yeah. So I'm going to ponder on that whole Lightning is layer 2, and the roll-up pieces are really the layer 1.5s or something.
So I'd like to point out, I guess, with the Lightning that it is pretty decentralized in terms of the data itself. Mm-hmm. So the data is not stored in any one place. There's data going back and forth that is only seen by the participants, basically. So it's not really possible to, one, snapshot it for if it was to help like the network function, but it also doesn't allow like surveillance per se through the whole network.
Right.
It's a type of like an onion structure, and there's no really central perspective. So the base chain, as most people are probably pretty aware of, it's all public.
Right.
So you can see these channels open, but then everything that it takes to get to that final settlement's kind of out there in the gray zone.
You know, I'm glad you just said that, because when you first actually defined scalability, that was the big that we probably should have pointed out there. So props to all the listeners who stayed this far to hear the correction that I think is really needed. There is zero privacy on Bitcoin or Ethereum. So when you had said like the scalability and it's like you want to do private, zero privacy.
Oh, I think I meant security.
Maybe. Probably.
That's what I meant. Oh, my bad.
But that is a common misconception amongst, I mean, people who've been in the space, since most of them are just speculators anyway. They feel that way too, like there's privacy here. And you know, because of the privacy coins like Zcash and Monero and a couple of the others, Dash, they haven't exploited, but they've made sure the fact is known that Bitcoin isn't private. Yeah. That's not as common knowledge on Ethereum. People don't think, and Ethereum is 1 billion times worse with privacy than Bitcoin is, because at least Bitcoin has some mechanisms built in where you're not supposed to reuse the same wallet twice. So it's very pseudonymous, right? Ethereum, everything's tied to one address, and because and this is one of the reasons I say like all these other chains are really alternatives to Ethereum, because they have to build this EVM module, right? The Ethereum virtual machine to run the smart contracts, and they want to do DeFi and NFTs with Ethereum, so they have to have the same coding base language, but that means you have to have the same wallet type language, which means if I know your wallet address on Ethereum, I know your wallet address on Binance, I know your wallet address on Avalanche, I know your wallet address on every EVM compatible and layer 2 chain, because it uses the exact same address across the board. But on the privacy, and why I bring all this up is because there's different approaches to privacy, right? You talk about the privacy, and a Monero and a Zcash and a Dash and a couple of the other privacy coins, they have this real strong belief that privacy first, everything else second. And I'm a huge privacy advocate. That's why I don't really do social media except for when we have to do crypto stuff. I did dox myself, everybody can sort of say it, but it's more for public trust. I think everybody else should not do everything I've done, right? And stay very, very private. But when you're talking about things like Bitcoin and money and the whole purpose of creating this, I hate when I hear people like, decentralization is the whole point. It's like, I hate that. It's not the whole point. It's the mechanism. It's how we achieve the whole point. Whole point is knowing what's happening with your money supply and making it the most predictable money supply possible. And you can't do that using central banks. They change it, they can print money, they can do whatever they want, and they can change it on a whim. Bitcoin is it, as far as we have seen thus far, that has had an unchangeable money supply that's predictable. I know how much money is going to be around. I know how much Bitcoin's going to be around in 20 years and in 200 years. And I know how much was there 10 years ago. I know all of it. And now, because of where Bitcoin maximalists are so needed, especially the vocal ones, is because on the social layer, right, they fight to make sure that change never happens. This is what the block size wars sort of was all about at a point. Who controls what, and not having control. But again, I don't want to sound like I'm getting too far off topic. The main reason we have to have transparency to make that happen. You have to have transparency to make Ethereum happen. So now how do you address privacy? And then there's that debate. Do you just use, like in Bitcoin, a lot of people feel like, well, privacy we can just accomplish through layer 2. We can do it through Lightning Network because, like you said, those are much more, especially now that we have Taproot, so you can even make sure when I go from Bitcoin to Lightning, no observer can tell I went from Bitcoin to Lightning. They just think I did a Bitcoin transaction. So now our channel, now that whole thing is private. And the same concept is around on Ethereum, like, well, maybe you can flip up and build privacy using zero-knowledge proofs and things. I think it's going to be a harder accomplishment in Ethereum for the privacy part than I think for you, Eric, or any input you have or questions you have on it. Can layer 2s or side chains, do they adequately help fix privacy and transactions?
I think it definitely helps. I don't think things are going to be completely private in like a digital world. You're going to be leaving like data behind. If you want complete privacy, you'll probably have to do it like on a physical level. So data itself probably can't, you can't be exchanging data but not have other people know what you're doing in terms of participating in a larger network. But the more that you can do on layers or side chains, especially ones that are geared towards privacy, the less and less data you're going to have that lots of people get to see. So I wouldn't be surprised if it is kind of like public knowledge, like who you bank with basically in the future, or at least to the government's perspective, where they see where your money went in and kind of where it comes out. But in terms of what you've been doing, whether you're going on traveling and spend your money somewhere else or doing all sorts of online activities or whatever, it won't really be something that's super easy to track if you're doing it on these additional layers. And that's likely to happen because there's going to be a big cost incentive to do that. The layers and side chains are being introduced. Part of scalability is that as more people want to do something, it drives up the cost of it. You got more demand for it. So as people go on to these additional layers, it's going to be cheaper, and that's just going to remove more and more data from that base layer. Okay. And then the other part of the money, just before we go back and forth, so you're talking about trying to create good money. The other part of these side chains or layers is to make Bitcoin or whatever base layer money more functional for a medium of exchange. So that faster transaction settlement is a major one, and then the cheaper costs.
Right. Have you followed? So in Ethereum, they're working a lot on for the real layer 2s. And I don't want to, for anybody who's on Ethereum, brought about Polygon as a side chain. They are simultaneously working on 2 different approaches to doing actual layer 2. And one of them is, all of them are using these things called roll-ups. You sort of touched on a roll-up earlier. It's like you're just sort of batching a bunch of transactions. But you have zero-knowledge roll-ups, and in Ethereum, you have zero-knowledge roll-up possibilities, and you have optimistic roll-up possibilities. Are you familiar with either of those two?
Just on a high level, just the general idea.
All right. This ties back to Bitcoin. So, with that, but so like I'm not a big fan of optimistic rollups for the same reason I'm not a big fan of like proof of stake yet. And that's because a zero knowledge rollup, without getting into deep cryptography and all that, but zero knowledge rollups are based off zero knowledge proof. Zero knowledge proof is a computer science theorem that I think stemmed from the late 90s, like we're talking about like 98, 99. They talked about it, Satoshi and a few of the early developers talked about it with Bitcoin, but they felt it was too new. And, again, you have to pick security and certain things. It's like you can't put something new if you want to sound secure. But now we're talking about like a little more than 20 years old technology for it. So it's getting another look in. What zero knowledge basically means is, how do I convey information to you? How do I prove to you I know something without telling you the answer, right? If you're going to be like, well, Nate, how old are you? Are you over 21? How do I prove to you I'm over 21 without telling you my age? You know what I mean? And showing you something that you can figure out my age from. And there's a lot of different examples of doing that. I think the Where's Waldo one is the best sort of example. So if everyone's familiar with Where's Waldo, you got to find the little guy with the red, white striped hat, right? In this huge crowd of people, right? And it's a puzzle. It takes forever to find the little Waldo sitting out looking at you. So I want to prove to you guys I know where Waldo is. I don't want to show you where Waldo is. And so what I do is I grab this. If the Where's Waldo is like on a regular sheet of paper, I grab a sheet of paper the side of like a house wall, right? And I cut one little hole in that. You cut one little hole in there, right? You punch a little hole in that wall and say, show me Waldo only. And I take the puzzle over to there and I just show you Waldo. Now I could have got lucky. So you don't know that I know. So you go, 5 feet away and punch another little hole. Show me Waldo again. Boop, there's Waldo. I don't show you anything but Waldo. And you can punch as many holes as you want to, and I'll show you. And every time I correctly show you Waldo, the probability that I know Waldo increases exponentially, right? And so I've just proven to you I know where Waldo is without, after so many times, it's more likely. It's just the probability is so high that I'm guessing it's close enough to zero to say it's zero, right? And so that's how zero knowledge proof works. Versus an optimistic rollup, which is the other approach that they're really looking at, and some networks are built on, like optimism as a layer 2. It's based off of optimistic rollups. It's just as the name suggests. You're optimistic that everything is sort of working out fine.
Oh, no.
And then you build in mechanisms where if it isn't fine, you have these reversion policies, but a certain amount of time goes through. And I compared that to proof of stake versus proof of work, because like proof of work, when you're talking about game theory stuff, right, it's competitive. I don't trust anybody. You're going to do proof of work, and I'm going to validate myself, and I don't care what anybody else says. I'm not looking for the overall network to agree on this transaction I did. I need to know the transaction I did is good. Versus proof of stake is more like, we don't think anybody's cheating. We're going to have a couple mechanisms in place, but that's why proof of stake has slashing. All proof of stake mechanisms have this concept of slashing, because if you do cheat, if a miner does cheat a validator for proof of stake, if they do cheat, they have to put up stake that will get slashed and punished. There is no punishment in a proof of work model, because you can't really cheat because everybody is just doing their own thing. And you can put something up. Your punishment is, we're going to disregard your block, and you've wasted that real world energy.
Yeah.
Right?
Yeah.
So similar to me with zero knowledge proofs, optimisms, which are two ways of looking at doing layer 2s, and that trans over to even Bitcoin, because you have the Human Rights Foundation, which is a good foundation everyone should follow. They just really base on look for like human rights across the world. They put out a grant, right, for people to work on layer 2 solutions using zero knowledge proofs, because again, it's been around. And this developer, I only know him from on Twitter. I can't remember his real name, but he goes by Litecoin, but not the token, not the project. He spells light like the actual word light, L-I-G-H-T. He got the grant.
Nice.
And so he's doing this thing called validity rollups, which is really just a way to batch all of the different kind of rollup concepts together, so you're not specifically talking about one type, right? And how you can apply that to Bitcoin to build a layer 2 that's scalable, adds privacy, especially if you're talking about some kind of zero knowledge proof rollup, adds your privacy on the layer 2 pieces, leaves Bitcoin base layer nice and open. I think it's one of the most interesting layer 2 developments happening on Bitcoin. I like the zero knowledge developments happen on Ethereum. I think they both address two different issues, though. Ethereum has a lot more to get done because it does so much more than just money. Bitcoin is like money. And so I think it's going to be a little bit easier if we could get the development, the community focus. Have you heard about any of these? Like the zero knowledge rollups or how they're getting used? And
Yeah, I think zero knowledge rollups are going to be an important part of privacy going forward. And kind of just my feeling is that they are being eyed by Bitcoiners as possibly one of the next major upgrades in terms of putting signatures on chain. That's possible, or it could be as a layer 2. In terms of, you kind of mentioned batching transactions for privacy.
Right.
That's another really good mechanism. And so Bitcoiners are working to make that something that's more like feasible for people. So CoinJoin is something that's a great privacy practice, the more people that do it. So that's basically if you've got several people that want to send money to other different people, and they basically put all their transactions together, and then it's hard to tell who's paying who if it's structured correctly. So doing something like that, batching transactions that then go into a privacy signature, that would really like obfuscate the exactly who's doing what, which is where the privacy is going to come from.
Right, because the privacy issue, on top of it being a public chain, you can just sort of look. But even when you try to hide, the issue comes, you got these companies like Chain Analysis who've gotten really, really advanced blockchain analysis tools, right? That I don't think Satoshi and the early developers even conceived, just like they didn't conceive of mining pools, right? Mining pools weren't in discussion until they popped up. I don't think they really conceived of like being able to analyze a blockchain like they're doing now. These methods all help with that, right?
Yeah, I was just reading an article yesterday about some super secret company, so secret I can't really remember the name, that's been doing some analysis for like different governments, and apparently they're tying in with like Internet of Things data, and they can start to use like some geolocation data to kind of figure out actual players out there. So yeah, there's definitely eyes watching, and there's people trying to hide their activities, and it's kind of a cat and mouse game out there.
On that, for when you talk about like layer 2 for privacy, so like this is Zcash's whole thing, right? If you're familiar with Zcash, Zcash is literally a direct clone of Bitcoin. It's not a fork. They didn't fork it. It's just a clone of Bitcoin. But they added zero knowledge proofs right into the core layer, although it's optional, which is like the biggest problem with that, because if you're the only person at a party wearing a mask, you're sort of standing out. Why do it on a layer 2 if you can do it on a layer 1? And like, what does Zcash got wrong on it? Are you familiar with it? Do you have ideas around it?
My understanding is it's not really possible to audit the total amount of coins in the Zcash, but that's just what I've been told. I don't know it for myself.
Yeah, that's what I've heard as well. You can't verify the supply. You have to trust that the supply was, I think they stuck with the 21 million cap. But I don't know that because, you had some, almost like a federation, right? It started with like a federation. They all had keys to launch the thing. And then they all said, I promise I burnt it.
Yeah.
How do you prove it?
And so your initial question was, why wouldn't you just do that instead of using a
Well, if
layer
it works,
two?
why wouldn't you just do it on layer 1 versus layer 2?
I think they're like, it's a large amount of data into a ZK signature. It's like 10 times the size of a normal transaction. So that would cut down it would either make the blocks big or cut down the amount of transactions that can be in there,
And
or
by
just be expensive.
doing that in the original programming, you mean like putting it, like writing it into the code instead of making a second layer?
Yeah, like you would basically do what would probably end up having to be a hard fork, which is contentious enough in Bitcoin. Not so contentious in Ethereum. They've like built their whole thing off of hard forks. You'd have to do a hard fork. That's a problem in and of itself, no matter what you're talking about. And then, yeah, you would implement, instead of doing zero knowledge roll-ups and batching to Bitcoin back and forth, it just happens raw. But the data size problem, I know that's the big problem with like ring signatures from like Monero, which is another privacy coin. They don't use zero knowledge. They use these things called ring signatures. It's interesting. It seems to work. They stay proof of work. I admire Monero, and I think it's really good if you have to do transactions right now and you need privacy, like take your Bitcoin, swap it for some Monero. You can do atomic swaps and stuff now.
Not financial advice.
Yeah. Well, I'm not talking about for gaining. I'm not talking about investment pieces, so definitely not financial advice. But if you need to if I need to buy something, I don't want the world to see what I'm buying. That's not happening on Bitcoin. You can hop through some hoops and make it happen through Bitcoin Direct or through like Lightning, or you could do like an atomic swap or something, or a peer-to-peer swap, trade some Bitcoin from Monero, and then do your real transactions in Monero and use it for transactional. I don't know that because, again, the supply issue and whatnot, I don't know that I would use it for my store of value piece, but definitely transactions. But the data piece is the big problem. We can't do that in Bitcoin because it makes the blocks bigger. And if the blocks get too big, Bitcoin's been around for we're celebrating the 14-year birthday on January 3rd. And in 14 years, the Bitcoin blocks chain size is 400, just under, I think, 450 gigs. Maybe it just went over, I'm not. But it's like about 450 gigs.
Yeah.
Ethereum, in contrast, because it does so much more, you're talking about like 1.5 or going on to 2 terabytes. So it's like 3 to 4 times bigger and been around half the time. And that makes it very hard for you, your everyday person, right, who wants to just learn more about it. Well, how do you sync up a node and whatnot if you can't even afford the storage space to do it, or the internet connection speed to sync it? Which can layer 2s help with even that, like syncing blockchains and be able to like run your own nodes and things like that? I don't know that I've heard too much talk about it. I know there's with Bitcoin you can do a full node, which you're downloading the whole thing, or you can just do a light node, right? Which is really you're just keeping with the headers, the core, the hashes of everything, not the actual transactions.
Yeah, so to participate in like layer 2, you are going to have a full layer 1 like data structure, or at least something recent enough that you can work off of. So I think in terms of in the Bitcoin space, Lightning really encouraged a lot of people to set up their own layer 1 nodes that wouldn't usually. And so that's been really good for like the physical decentralization. Now that you can do something a little more interesting than just validate blocks coming through, that you can kind of, and you could always use it to send out your own transaction. But there's so many interesting things happening on Lightning that people want their own hardware to do it, and they have to have layer 1. And because of the way the layer 1 is structured, that's feasible to do on some like basic hardware with a basic internet connection, whereas you couldn't really do that with Ethereum. You would need like a $10,000 computer to really participate directly.
But like if you, like for me, for example, if I wanted to participate in Lightning and have like is participating in Lightning, does that mean like having a Lightning wallet? Is that all that means? And like sending transactions?
That's a form of participation for sure.
Because I'm not sure. I have a Lightning wallet, but I don't believe I have a node.
Yeah,
I mean,
you're
that's what I
likely
downloaded.
using a custodial service of someone that's got the node itself. There's probably various tricks so that they can't really spend your funds, but you still are relying upon them to monitor the network for you, which is another part of like layer 2s, is you kind of always have to be watching layer 1 to make sure your counterparties aren't pulling any tricks on you.
Right. But that's an issue even without Lightning, right? If I just use a software wallet, unless I'm tying it back to my own full node, they can't spend my Bitcoin, or this is true with any of the networks. Like Ethereum just had this realization, a lot of the users had the realization. I would argue most people who use Ethereum use actually the Ethereum network, not just like speculate on it, use MetaMask. And MetaMask, by default, the node you use is called Infura, which sits on like AWS servers. It's very centralized in and of itself. Again, they can't spend your Ethereum, but this is where when you hear about censorship happening, well, it's because you're using this Infura node, which is like this centralized company, which is based in the U.S., and they want to follow U.S. policy. So when U.S. says ban that transaction, they do. So you'd have to set up your own Ethereum node, which becomes much more difficult than it is on a Bitcoin node type setup. But the same thing can happen on Bitcoin. If you're using a software wallet, I'm a big fan of like Exodus wallet, right? It's very easy user interface. Same thing's true with like a Blue wallet if you're a Bitcoin only, whatever. If you trust, when you use those wallets, you're using their nodes. They can't spend your Bitcoin, but you're trusting that what they're telling you the state of the blockchain is right now is accurate. They could be 5 blocks behind. They could be making up blocks in the future. You don't know what the real state is because it's not yours. Again, that's sort of the key difference, right? With Bitcoin, it's like run your own node. You're not, even if you're not mining, you're not participating in the network in any meaningful way of participation. You're participating in the fact that I don't care about the network. I care about my transactions.
Yeah.
My blockchain, my version of the Bitcoin blockchain told me that Eric has a Bitcoin to send me. And then when he sends it, my copy of the Bitcoin blockchain told me it's now in my wallet, no longer in his.
Yeah.
I'm only trusting my node, and if you're not running your own node. So even though, yeah, Lightning, you're still trusting. If you're not running your own node, you're sort of still trusting anyway, which could be fine, maybe, depends on what you're trying to get out of it.
Yeah, the deeper you get in the space,
Yeah.
the more you can participate, basically. So you want it so that a newbie can just start up with their phone with very, few obstacles and not a lot of cost. But then if someone wants to be like really deep and a very active participant, you don't want to have obstacles to that level as well.
All right. Before we wrap up, on the Bitcoin side, what's the most interesting thing to you that's sort of coming up on that layer 2 or side chain or scalability piece? What's coming up that they're working on that might be useful?
I think Lightning itself is enabling like a lot of microtransaction based exchanges. That's what I find really interesting. So whether you're paying per the minute of a podcast, like here, and then that allows you to like gauge like the interest. You can see where do people tune in, where do they tune out.
Right.
Or let's say you're like renting a car or renting like a space, you could be paying by the day or something like that.
Right.
So having things so that transactions can happen quickly, possibly be programmed, that allows a lot of new types of like contracts that are based upon like shorter time intervals.
You brought that up. We haven't talked about that, and I think that's the last important piece we should mention real quick is how do layer 2s or side chains, how do they fix the fee problem? Is there such a thing as a fee problem in your opinion, and can layer 2s fix the fee problem?
Yeah, they fixed it because the fees aren't too bad. I sent $1 of Bitcoin yesterday, and there was like a 30-cent fee on it, which is very high, like, percentage-wise.
30% fee.
But in terms of, dollars, like just an example, the fees right now are less than $1, and that is because of Lightning. Lightning is absorbing so much of these like small, like frequent transactions that people aren't doing that on layer 1 anymore.
Well, what would the fee if you sent the dollar on Lightning? What would your fee be?
Penny. But if you were to try to send it on Ethereum, it'd probably be like $30 or $20 right now.
No, I think it'd be cheaper. Yeah, it's about, if you're sending Ethereum to Ethereum, you're paying maybe a couple bucks. So, I mean, so you probably couldn't send $1, but but it's not like $30, $40 anymore unless you're doing these complex DeFi transactions. But that can be too much. You know, $1 is a lot. 30 cents is a lot. You know, but yeah, that's the thing. That's the other part. Layer 2s are really supposed to solve across, I think, all networks is the fee problem of, you know, again, with Bitcoin being the base, even in the days of like Hal Finney and Satoshi and all of them talking about it, Hal Finney had the perspective that I think I mostly agree with, that, you know, you're not getting rid of banks. Banks will just start using Bitcoin. Satoshi was always, even in the white paper, he's like, you're not going to have a bunch of individuals running miners. It's going to be like data centers who are running miners. It's going to be the Googles and the Amazons and all of that, which is okay, especially some of the progress we've seen now in like with the user-activated soft fork and stuff, that individual nodes who aren't miners have power in the network as well. It's not just about the miners. But the fees will be exorbitantly high, but that's because most people won't be operating on that base layer, right? Most people will be operating on like a Lightning network or some other layer 2 network. I think we should definitely focus on having multiple layer 2 networks on every thing, so you're not centralizing all the power in one even alternate. If something happens with that alternate, even if it's decentralized but there's a software bug, you have another alternate to go to. But yeah, Lightning fees are almost free at this point. You're paying, you know, a Satoshi or two versus cents. And then with Ethereum, the same thing. A lot of people were misconceived. They weren't lied to. They just didn't have the information that moving to proof of stake was going to do nothing for fees. Fees didn't drop because of proof of stake. Fees dropped because we're in a bear market at this point in time, in, you know, late 2020 going into 2023. Nobody's using the network. Fees drop down. That's why they're much cheaper. Layer 2s are where you're saving on fees, and that's because in a different manner than Lightning, but their layer 2s use these different things. You're transacting there. And I mean, they're still not even dirt cheap. Nothing's as cheap as Lightning Network that I know of, unless you have a very highly more centralized entity doing things for a layer 2. But you're paying like a couple pennies versus a couple dollars on Ethereum or whatnot. So yeah, layer 2s and fees are a big thing. But yeah, I think that's it. So let me ask you again, what is, to you, what are layer 1s, layer 2s? What does scaling even mean? What's it all about, Ashlee?
Well, I kind of think I got layer 2s. Well, I don't think I define layer 2s, but so layer 2s are a layer on top that can help that can help with the scaling without the base layer compromising in one of its trilemma areas.
Okay.
Side chains are kind of the same thing, help with scalability. So they're all like intertwined. They all help with scalability.
What's scalability?
And scalability is so that to help users to use it and to have like faster transactions and yeah.
Okay. How do you feel about that?
Yeah, scalability is more transactions.
Yeah.
Let everyone send all the money they want.
Yeah, like let more people use it.
Mm-hmm. So that was it. We'll go, I guess, take more deep dives. If you have more questions, you know, for anything we talked about, because some of it can get technical, and this was a more advanced sort of episode and whatnot. So definitely go to theblockument.com. We'll have links to multiple resources, like, you know, resources about Lightning, resources about some Ethereum layer 2 things. I'll link over to like Litecoin's work on validity proofs and whatnot, which I think will be, he's building that for Bitcoin, but I think the research can be used across chains. So go to theblocument.com, find those resources. Eric, somebody wants to reach out to you and ask you more questions. How can they reach out to you or whatever?
They have to find me in person.
Yeah.
Find them.
Hunt them down.
You can probably find me at the Crypto Sharks in Livonia with Ashlee.
Okay.
And then on Wednesdays, me and Nate are usually down at the Detroit Beer Company. So come check out the meetups.
Those are your
That's
two
right. So if you want
opportunities to hunt them
you
down.
want some of that, yep.
He's
The best
not
you can
on
get is come to
social.
Detroit, and he gave you 2 spots. You can
Yeah.
maybe find them. He's like, where's Waldo except with Eric? Where's Lightning Eric? You can find us. We're a little bit easier to find.
Yeah,
You can find us on Twitter, TikTok, and Facebook. All of them at The Blockument. Always just come to theblocument.com. You can link to all of that stuff. And anything else you want to add, Ashlee?
No, that's basically it. I mean, definitely come check us out on the socials, leave us comments, ask us questions, call in when we are live. This is not a live one. But yeah, definitely interact with us. Let us know.
Yep, reach out, especially like in the YouTube comments or in on Twitter. If you have more questions about what we talked about, we want us to dig in on another episode, going even deeper into any of the topics, drop us a line. We'll either answer it there or we maybe make a whole show about it.
Or if you want to be a guest, let us know.
Yep, we emphasize all everyday users on our guests. We can do Zoom things. So if you got something to contribute or you have really good questions, maybe you have nothing to contribute on the answer side, but you have just tons of questions like Ashlee does.
Me.
Reach out to us and we can see. So until then, while this was a technical discussion, I still think most people come to crypto and Bitcoin for the money and the speculation. So come on for the riches.
And stay for the revolution.
Stay for the revolution. We'll check y'all next time.
See you later.